So for this discussion, we're looking at discussion 3.3. This one says create and post two visual mappings. The mappings need to represent a relation that is a function and a relation that is not a function. Identify the domain and range of each map. You can refer to pages 200 to 202, but you need to create your own maps. You can ask classmates to pick which map is a relation and which map is a function. So before we go into that, let's just go over what a function is and what a function isn't. And I have 9 examples up over here, and we're going to look at some of them that are functions and some that are not. Now, in order to be a function, it would have to pass something called a vertical line test. Now, I have specific functions here. These are very specific, and we can just go over some specific ones in terms of just points as well. There's so many different ways you can go about this. I'm just going to look at some equations in some of these graphs here, and I'm just going to come up with some points from the graphs. Now, you can pick any random points as well as a set for a function as well. It's just that it's really your choice. So let's start with these examples since I have a nice visual here. So in order to be a function, it has to pass the vertical line test. So look at the vertical line. As I go to draw vertical lines through this graph here, no matter where I draw a vertical line, no matter where it is, it will only pass through the graph once. And what that means is for every x value, there is one y value. So each x value can't go towards more than one y value. And we're going to see in a second here with some of these that it will go to 2. But for this first one, this one is a function. So that is a good function right there. That's a function. Now the one right below it is not a function. And so if I go to draw a vertical line, say at that x value of 1, it crosses the graph twice. Once right there, another right there, at 2 and negative 2. So an x value of 1, I end up having 2 y values, which makes this not a function. So number 2 here, no matter where I draw a vertical line on here, no matter where I draw it, it'll only go through the graph once. So that one is a function. Same thing with number 3. No matter where I draw a vertical line in here, it's only to go through once. Therefore, it is a function. Same thing with number 5. No matter where I draw it, it's going to only cross once. With number 6. Number 6, if I draw a vertical line there, it goes through twice. Once, twice. Therefore, this is not a function. So that's just six examples of functions and not functions. But now this, what this discussion asks you to do is to use a mapping of some functions. So let's take a look at what mapping means. So the first thing I'm going to do is I'm going to grab some points from number 1 here. So number 1 is y equals 3x minus 2. So y equals 3x minus 2. Okay. So some points for this would be, let's see here, let's plug in 0. We plug in 0, 3 times 0 is 0, so it's going to be negative 2. If I plug in 1, I end up with 3 minus 2, which is 1. If I plug in 2, so I plug in the x value of 2, 3 times 2 is 6, minus 2 is 4. We'll grab 2 more points. We'll do 3. 3 comma, okay, 3 times 3 is 9, 9 minus 2 is 7. Now if you notice here, each time I go up 1 for the x, it so far has gone up 3 on the y because the slope is right there, which is 3 over 1. And so since it's 3 over 1, every 1 I go up on the x, I go 3 up on the y. From negative 2 to 1, that's 3 spaces. From 1 to 4, that's 3 spaces. 4 to 7, that's another 3 spaces. And then the next one is going to be 3 more spaces, which is 10. And so if you do that, you do the math, 3 times 4 is 12, minus 2 is 10. So here's my points. Now that is not a mapping. That's not a mapping. This is going to be a mapping. So in my map number 1, which is going to be my x. Now this is the x I'm just listing here as my independent or my input. It could be labeled something else, but this one here is your independent. And the y is what is dependent on the x. So I plugged in 0, I plugged in 1, I plugged in 2, I plugged in 3, I plugged in 4. This mapping over here, the independent is also the domain. It's also the domain. Now, in this particular mapping, I came up with only 5 points. So of those 5 points, 0, 1, 2, 3, 4, that is the domain. That's what x can be. Now technically, I can plug anything in for x. And so the domain of the whole entire function is this little fancy r, meaning all real numbers. And now the same thing with the range. The range, if we go back to the graph here, let's go back to the graph. Now this line does continue on forever up and down and left and right. And so that range is also all real numbers. Now, that's okay, but say you're doing a mapping and you're just coming up with some points and you don't even have this line and you just came up with just these points. The x values are your domain, the y values are your range. So here we go. And so -2, 1, 4, 7, and 10. And so to map something, you're basically showing what it maps to. You're showing the points. So 0 goes to 2. The 1 points to the 1. The 2 goes to the 4. 3 goes to the 7. And 4 goes to the 10. Now, again, for this one here, I actually did start with a function. In order to map some stuff, you don't need to start with an actual equation. So you don't need to start with an equation. You can actually come up with a set of 5 or 6 points. And then all the x values are your domain, all the y values are your range. Because technically for this, I don't have all of the points listed. It would actually be impossible to list all the points because the line goes on forever in 2 directions. It's impossible to list all the points. So I just listed out 5. And that's the other reason why I said, hey, the domain is all real numbers, and the range is all real numbers as well. So when I look at my actual graph, the equation I had, I have an infinite amount of points. But for your sake, for this mapping technique, you can actually just come up with some points. I was just coming up with general points that came from that line. But for argument's sake, I'm going to come up with an example now. And this time, I'm not going to use an equation. I'm just going to come up with some random points. And this one is not going to be a function. So let's take a look here. So I'm going to go with 10, comma 4, -4, comma 6, -3, comma 4. Oh, I'm going to put that 14. And then we'll do -4, comma 8. And then we're going to have, let's just do one more random point. We'll do 9, comma 2. So I came up with 5 random points here, just random. So your x's are your domain. So these here, well, do these points represent a function? Well, we're going to find out right now. So x here, my x values are my input values. Now, usually you want to write those in order. I'm going to make that circle a little bit bigger, or the map a little bit bigger so I can fit them all in. Now, it's usually best to put them in order. So we have -4, -3, 9, and 10. Now, you don't have to, and it's not good to actually do the duplicates. You have two -4s, and so it's a duplicate. And these should actually be some much better ovals. So let's see, can I make an oval? Let's try to make a much better oval than this. Huh, there we go. I should have started out with that. Now we're rolling. All right, so let's take a look at the y values. Let's put those in order. So we have 2, 4, 6, 2, 4, 6, 8, and 14. And these are my y's. And so these guys here, since I only have points, this is my whole entire domain. So my whole entire domain, and now because I have specific values, I'm going to put it in brackets. So my domain are these values here. And these are specific finite because I'm telling you, I'm only starting with the points. I'm not starting with a graph, not starting with an actual equation. So my domain are what x can be, so that's the x values. The range are my y values, what y can be. And that's the y values, 2, 4, 6, 8, and 14. Okay, so now let's map them here. So let's take an arrow here. We're going to map them. So the -4 points to the 6. The -4 also points to the 8. The -3 points to the 14. The 9 points to the 2. 10 points to the 4. Ooh, that's some crazy stuff going on there. But the key here is this, the 4. The 4 points to more than 1. So you have an x value pointing to more than one y value. What that means is this will not pass a vertical line test. And since this will not pass a vertical line test, I have an x value pointed to more than one y value. This is actually a mapping diagram that shows that it is not a function. And so just to clarify one more time, the x values are my domain, the y values are my range. I just created a set of 5 points. Now the set of 5 points can represent a function, or it may not. In this case right here, it does not. So your job is to make sure, let's go here, make sure we view this here. So you want to create and post 2 visual mappings. The maps need to represent a relation that is a function, a relation that is not a function. And then it says identify the domain and range of each of your maps. Next, it says, let's see here, it says, let's see here. So you can refer to those pages where you need to create your own maps. Ask your classmates to pick which map is a relation and which map is a function. So when you're responding to your classmates, make sure you explain which one is a function and which one is not. And make sure you explain why it is or why it's not. And so hopefully this video helps you get started with discussion 3.3. If you need any assistance, please let me know.